We shall be presenting the facial makeup matching system, and then we shall start by with the problem statement. Developing an AI-driven virtual makeup system that adapts to diverse facial features, culture, beauty norms, and real-time user preferences while ensuring inclusivity, privacy, and seamless performance. Why are we doing this system? First of all, it will bridge the personalization for the makeup. Like each person will get a makeup that's recommended just for them and for their skin type and their facial structure. And then this is also critical for the users because it will be a product that the users can trust. Some of the objectives of our project include the following. First is to enable real-time virtual try-ons, and then you also have to deliver hyper personalized makeup recommendation. This is what I was explaining, where a user will get makeup that's personalized just for them, and then also align AI recommendations with the professional expertise. So our professional expertise are the makeup artists that are already in the field that have the expertise in the makeup are able to recommend the makeup to their clients. So how we obtain our dataset and how we're able to use it. So first, I will use the web scraping tool to get images from Google, and then we wrote some Python code to do some face cropping, and here we're able to obtain two folders, one with makeup and then another folder without makeup. We're also able to crop faces from the CPM SYNT2 dataset that's publicly available, where this one had pictures of people with makeup and without makeup. So we're also able to get those images from that dataset, split them, and also crop them. And the graph shows the images of the percentage of the images with the makeup and without the makeup. Uh, what's the impact and relevance of our project? So it empowers beauty industry professionals and individuals, and it also supports digital transformation in the cosmetic sector. It reduces trial and error in makeup selection, saving money and time. This is a case study of someone, in order, like how it's happening right now, in order for someone to know how the makeup looks on them, they have to first try on and then are able to tell that this makeup is for them or they don't like it at all. And it also promotes inclusivity by catering to diverse skin tones and preferences. And it's also aligned with the UN Sustainable Development Goals. With gender equality, it empowers women in beauty and tech industries. And then also the industry innovation and infrastructure. There's advances in AI application in beauty. And then also reduces cosmetic waste uh, due to the virtual try-on and it's able to tell that this is the perfect makeup for someone. And then the target users and beneficiaries, we have the makeup artists, beauty professionals. These ones are able to enhance the client recommendations. And then we also have the retailers and e-commerce platforms with the virtual try-on boost sale. Here, the e-commerce platforms that sell makeup are able to implement the virtual try-on on their website, and this can boost their sales. And then also have consumers and then makeup people that love makeup here personalized AI-driven beauty guidance in how they can apply the makeup and how the makeup will look on them. And then tech innovators and AI developers, it will also create advanced, it enables advancing AI in beauty tech. I will welcome my presenter to start from here and explain the models and techniques. Thank you.
Good evening. I will proceed from where my colleague stopped. I'll be explaining the models and techniques we used and why we used them. And yeah, so basically we had 5 models, but we used these 4 because these were at least the ones that gave us something. So we had the pre-trained VITs, the SVMs in knowledge distillation, logistic regressions, and then capsule networks. So, of course, the pre-trained VITs, they gave us the highest accuracy. And why? Because mm, yeah, it had superior accuracy and it had robust feature extraction and it had excellent generalization as well. But then it just had some limitations, which were high computational costs and lower interoperability. And that's why it wasn't at 100%. Then SVM with knowledge distillation, well, it had perfect accuracy for the datasets we had. And then it had also good knowledge transfer and it was efficient with its learning. But its limitations, it's very complex. It's a very complex training process, and then it requires careful tuning. Then next we had logistic regression, which had high efficiency and model interoperability, and also it was simple to implement. But it had lower accuracy than the rest of our models. And then the linear decision boundary was also not the best. In capsule networks, that was ours, I would say. It had some key strengths. Its feature interoperability was good, and it had also good hierarchical representation that other models didn't have. But then it was very poor with its accuracy, as you can see, at 48.86%. And yeah, that's why I'm at the list. So the implementation of our models, we used Python, the programming languages, and then the libraries and frameworks that we use OpenCV, and then as scikit-learn, and then NumPy, PyTorch, TensorFlow, Keras, Seaborn, and Matplotlib. In the platforms that we use Google Colab, Jupyter Notebooks, and Hugging Face. And then the visualization tools, we use TensorFlow, Seaborn, and Matplotlib. So this is our proposed system architecture, where we have the client's view and then the server view. So the client inputs a picture of himself, and then the system will have to detect all the features on the person's face and then produce a picture with the user having the makeup. So this is basically how the system would work. And this is a live preview of how it works. So basically, the pre-trained VIT, these are the results that we had, and it had 95% accuracy, precision, and recall F1 score. And then the monetization and the scaling of this system, where our revenue source would be to users paying a monthly fee of $0.25 for virtual try-ons, and then for makeup artists, they would pay 12.25 per month for AI recommendations for their clients. And then beauty brands or businesses that produce their makeup, they would pay $120 per month for their product visualization. So generally, we're estimating about $4,000 per year. And then the market opportunity, well, if we're to look at the women, let's say, on a global basis, there would be about $5.3 billion that we'd get from the number of users. And our strength of this system, well, it's an AI-powered system. It's affordable and it's inclusive of all features, of all skin tones, of all that. And then the weaknesses, of course, there's high initial AI training costs and internet dependencies. So the team contributions, we have Eddie who did the EDA, exploratory data analysis, and then Lindsay who did model development, and then Eddie who did the model improvements of knowledge distillation and adversarial learning, and then both of us worked on a concept paper and the business model canvas. Thank you for going through this slide with us, and if you have any inquiries, please reach out to us on the details provided. Thank you.